Have you ever wondered what's at the center of a black hole? This question may seem like it's pulled straight from a science fiction novel, but it's a genuine conundrum that scientists grapple with every day. Black holes, these fascinating and mysterious entities, are regions of space where gravity is so strong that nothing can escape, not even light itself. So what exactly are black holes? Picture the remnants of massive stars much larger than our own sun, that have undergone a powerful and violent event known as a supernova explosion. The star collapses under its own gravity and a black hole is born. It's a place where the laws of physics as we know them seem to break down, and space and time as we understand them cease to exist. They are the universe's greatest mystery, a riddle that continues to perplex scientists even today. But why are black holes so mysterious? Well, let's delve a bit deeper into this cosmic enigma. At the heart of this mystery lies the concept of the event horizon. Picture this, if you will. It's a boundary, a sort of cosmic point of no return, beyond which nothing, not even light, the fastest thing we know of, can escape. This makes the event horizon a veil, cloaking the inner workings of black holes from the prying eyes of our telescopes. Now let's talk Einstein. His theory of general relativity, a cornerstone of modern physics, predicts the existence of black holes. According to this theory, massive objects cause a distortion in space-time, which we perceive as gravity. And in extreme cases, like with supermassive stars collapsing under their own gravity, this distortion becomes so intense that it forms a black hole. But here's where things get really interesting. Einstein's theory also predicts that inside a black hole, space-time becomes infinitely curved, forming a singularity. This is a point of infinite density and zero volume, a concept that seems to break the rules of physics as we know them. Now onto the paradox of information loss in black holes. This is a conundrum that has been puzzling physicists for decades. According to quantum mechanics, information about a system's state can never be destroyed. But if something falls into a black hole, and the black hole eventually evaporates as Stephen Hawking suggested, where does the information go? It's a paradox that remains unsolved. And let's not forget the concept of spaghettification. If, hypothetically, you were to fall into a black hole feet first, the gravitational pull at your feet would be so much stronger than at your head that you'd be stretched out like a piece of spaghetti. Black holes, quite literally, defy our understanding of physics. They are a testament to the vastness of our universe and the mysteries it holds. So, while we've unraveled some of the mystery, the enigma of black holes still keeps us gazing up at the night sky in wonder. So, what's next in our understanding of these cosmic beasts? The quest for knowledge never stops, and the same applies to our pursuit of understanding black holes. Scientists around the world are working around the clock, using some of the most advanced technology and brilliant minds to delve deeper into the mysteries of these celestial enigmas. One of the most remarkable endeavors in recent years has been our attempt to capture the image of a black hole. Sounds impossible, right? After all, black holes are known for swallowing everything, including light. But through the Event Horizon Telescope, a global network of radio observatories, scientists achieved the previously unthinkable. They captured the silhouette of a supermassive black hole, providing us with the first ever visual evidence of these cosmic beasts. Then there's the study of gravitational waves. These ripples in the fabric of space-time, first predicted by Albert Einstein himself, offer a unique window into the universe. The detection of these waves, often produced by the collision of black holes, not only confirmed Einstein's century-old prediction, but also opened a new avenue in astronomy. And why are black holes so important, you might wonder? Well, they are key to understanding the fundamental laws of physics. They challenge our understanding of the universe and force us to question our theories and assumptions. They might even hold the answers to some of the biggest questions about the universe's origin and fate. Remember, we're still in the early stages of our understanding. With every new discovery, we rewrite our understanding of the universe. And each question we answer only leads to more questions, pushing us further down the rabbit hole of cosmic mystery. As we continue to unravel the mystery of black holes, we come closer to understanding the very fabric of our universe. The quest, as they say, continues. Thank you for watching. If you enjoyed this video, give it a like. Craving more? Hit subscribe and journey with us through the realm of learning. Remember, every thumbs up and every subscription fuels our passion to deliver more. Become part of our learning community today.